Is the screen shared to you?
Yes, madam.
So today we are going to discuss about algorithm design techniques that we follow. So we have mainly 5 algorithm design techniques: divide and conquer technique, greedy method, dynamic programming, backtracking, and branch and bound. So in the last class we have discussed about what is an algorithm and what are its characteristics, how to analyze an algorithm. That means how can we know the performance of an algorithm, that is by computing space complexity and time complexity, and how to calculate the time complexity and space complexity. And we have seen some applications like searching and sorting. And we have seen some applications how to compute the time complexity for the applications. And I told you we can find the time complexity for a given problem or given example or application by using recurrence relation for some applications, like the applications which we use divide and conquer technique. So divide and conquer technique mainly follows 3 steps. So whenever you are unable to solve the problem directly and where the problem is complex, you will going to apply this divide and conquer technique. So first you are going to divide the problem into subproblems. Up to which extent you are going to divide means until you can't divide that subproblem into subproblem further. So up to that extent you are going to divide the problem, and once dividing step has been completed, you are going to find the solution for each subproblem. So you are going to recursively find the solution for each subproblem, as this each subproblem is independent. So once you find the solution for each subproblem independently, and at last you are going to combine all the solutions of the subproblems to get the solution for the given original problem. So these are the 3 steps mainly we will follow in the divide and conquer technique. So in divide and conquer technique, we have the applications like quick sort, merge sort, binary search. So already we have seen these applications in the last class while discussing about the searching and sorting technique. So binary search by dividing the list into 2 lists. That is by finding the mid element, and you are going to search your element first with the mid element, and if it is less than you will go for the left search, or if it is greater than you will go for the right search, right sublist, like that. And then by placing the pivot element and starting from the left side, you are going to check whether the pivot is less than or equal to the lowest element. If so, we are going to increment the lower bound, and at the same time you are going to decrement the upper bound if at all your high value, that means a of high position on a value greater than or equal to pivot at, we are going to decrement the upper bound. And when both get stopped, and you will check whether the positions of the lower bound has crossed the upper bound or not. So based on that you are going to do some swappings. So by this you are going to place the pivot element in the correct position, and the list before the pivot element is going to be the elements which are lesser than the pivot, and the elements to the right side of the pivot will be greater than the pivot. Like that you are going to repeatedly apply this until the complete list is going to be sorted. And whereas merge sort, you will divide the list into 2 lists, and again you will take the left sublist, and again you will divide the list into sublist by finding the mid element. So like that you are going to divide. Once the division complete అయిన తర్వాత merging, సో మీ 2 elements ని కంపేర్ చేసుకుంటారు, అండ్ 1 2 సార్టింగ్ ఆర్డర్ లో పెట్టిన తర్వాత you will be compare with third element, and 1 2 3 ప్లేస్ చేసిన తర్వాత సార్టింగ్ ఆర్డర్ లో 4 5, and 1 2 3 4 5 సార్టింగ్ ఆర్డర్ లో ప్లేస్ like that. So finally you are going to have 2 sublists which are in the sorting order individually. Again you have to merge those 2 lists in the sorting order. Again you are going to have the comparison with the first element in the left sublist will be compared with the first element in the right sublist, and which element is smaller, we will put that in the sorted array. Those elements which you kept, that element, that array pointer will get incremented and will be compared with the other element. Like that, merge sort takes place. So all these applications follows divide and conquer technique. So merge sort kani, quick sort kani, binary search kani, like matrix multiplication. So normally matrix multiplication requires order of n cube, but whereas that means it consists of 8 multiplications. So when you go for the multiplication of 2 matrices, but in order to improve the time complexity of matrix multiplication, a person called Strassen has introduced a new method such that he has reduced the time complexity to calculate the matrix multiplication from order of n cube to order of n power 2.81. So he has reduced one multiplication. So instead of 8 multiplication, he has reduced to 7 multiplications. And he has increased the number of additions as well as number of subtractions. So that he has reduced the time complexity from order of n cube to order of n power 2.81. So all these applications comes under the divide and conquer strategy. So one more example is maximum and minimum also, which comes under the divide and conquer strategy. So finding maximum and minimum. So if the list contains only one element, means if I equal to j, then that is the max element and that is the min element. If the list contains two elements, if I equal to j minus 1, then you are going to have one condition. If a of I less than a of j, then a of I will be the max, otherwise a of I will be the min. So like that. So else, if the list contains more than two elements, then you are going to find the mid element. So mid equal to I plus j by 2, and you are going to call again max min for the elements I, mid, max and min. So for this you are going to apply divide and conquer strategy. So we can have the time complexity T of n equal to 0 if n equal to 1. Time complexity is 0 if n equal to 1, and if it is 1 if n equal to 2. As two elements into, we are going to have only one comparison. If it is more than two elements, we are going to divide by finding the mid. So 2 into T of n by 2 plus 2 if n is greater than 2. So when you solve this recurrence relation by using substitution method, T of n equal to 2 into T of n by 2 plus 2. So we are going to have the time complexity of order of n. So how to solve this recurrence relation means 2 into T of n by 2. So T of n by 2 place lo, again you have to substitute. So T of n is given as 2 into T of n by 2 plus 2. So T of n by 2 value, how will you get means, put n by 2 in place of n. So 2 into T of n by 2 by 2. So T of n by 4 plus 2, and again we have plus 2. So T of n by 4. So this is going to be 4 into T of n by 4 plus 4 plus 2. So when you go on doing up to k times or k minus 1 times, so you are going to have some equation. So in solve chesnaka, put n equal to 2 power k, n equal to b power k అనేది మనం substitute చేస్తాం. ఇక్కడ b value is, actual general equation is T of n equal to a into T of n by b plus f of n equation తో మనం represent చేస్తాం. So like this, a into, if you want to solve the recurrence relation using master method, so the general form of the recurrence relation is T of n equal to a into T of n by b plus f of n. So we are going to have three cases. So if f of n equal to order of n power c and ఎప్పుడు అవుతుంది అండి అయినప్పుడు, where c less than log a base b, then in that case we can call T of n, time complexity is n power log a base b అవుతుంది. And in the other case, where c equal to log a base b అయినప్పుడు, then T of n time complexity is going to be n power c log n. So the third case, if c is greater than, so c అంటే ఇక్కడ మనం f of n ని, if f of n is of the form n power c అనుకుంటే గనుక, ఆ based on c value ని బట్టి, if c less than log a base b నా, c equal to నా, c greater than అనేది మనం చెక్ చేసుకుంటాం. So depending on that, we are going to decide the time complexity for that recurrence relation using master method instead of solving using substitution method. So this is the shortcut way to find the time complexity for the given recurrence relation using master method based on the condition. Here you have to assume the given function f of n is of the form n power c. So you need to check whether c is less than log a base b or c equal to log a base b or c greater than log a base b. So if c equal to log a base b అయితే time complexity వచ్చి n power c log n అవుతుంది. If time complexity is going to be theta of f of n. And if it is c less than means n power log a base b. So for example, here our recurrence relation is 2 into t of n by 2 plus n అనుకున్నాం. So f of n place లో మనకి n ఉంది. So we have to assume f of n is of the form n power c. So n power c అనుకుంటే c place లో here we have c value is 1 as f of n is n కాబట్టి. So now a value is 2, b value is 2. So you need to check c value is 1. So 1 less than or 1 equal to or 1 greater than log a base b na అనేది check చేయాలి. So log a base b, log 2 base 2. So it is going to be 1. So our c value is also 1. So it comes under case 2. So as c equal to log a base b, time complexity is going to be n power c log n. So c value 1 kabatti n log n అవుతుంది. So that the time complexity for this recurrence relation is n log n అయింది. So f of n form అనేది n power c form లో ఉండాలి. And you have to check whether c is less than a, c equal to na, c greater than log a base b na అనేది check చేసుకొని depending on that you have to write the time complexity. If c less than log a base b, time complexity is n power log a base b. If c equal to log a base b, time complexity is going to be n power c log n. If c is greater than log a base b, then time complexity is going to be f of n. So based on these conditions, we are going to solve the recurrence relation to find the time complexity using shortcut way. Using substitution method of solving the recurrence relation is somewhat time taking and difficulty. So we will follow this master method to find the time complexity of the given recurrence relation. So if you see here 2 into t of n by 2 plus 2 అయింది n power c. c value వచ్చేసి ఇక్కడ f of n ఏమైంది ఇక్కడ 2 అయింది. f of n is constant. So n power 0 we have to assume n 0. Okay. So depending on that condition you have to write. And this is the application matrix multiplication which comes under divide and conquer strategy. So if we follow normal matrix multiplication, we are going to have n cube. Okay, as the equation is 8 into t of n by 2 plus n square. So 8 into t of n by 2 plus n square means for multiplication, for addition you are going to have 8 multiplications and plus we are going to have 4 additions. So for addition of 2 matrices, we are going to have time complexity of n square as we are going to have 2 for loops in that matrix addition program. So manaki ikkada 8 into t of n by 2 plus n square. So if you solve this equation using master method, you are going to have n cube. But if we follow Strassen's method, we are going to have only 7 multiplications. So 7 into t of n by 2 plus n square. So when you solve this, you are going to have order of n power log 7 base 2. And log 7 base 2 value is 2.81. So it is going to be n power 2.81. So like that we are going to calculate the time complexity. So main ga meeku time complexities meede questions vastayi ekkuva. What is the time complexity for the given applications? What is the worst case time complexity, or what is the average case and what is the best case? So most of the questions that comes from the time complexity is maximum. So which application comes under which technique? So whenever match the following అలా కూడా వస్తుంది, కొన్ని అప్లికేషన్స్ ఇస్తారు అండ్ కొన్ని algorithm design techniques. So which application is solved under which technique, they will ask. For example, if we give merge sort, so it solves under divide and conquer strategy. Quick sort, divide and conquer strategy. If we give fractional knapsack problem, that can be solved using greedy method. If it is 0 or 1 knapsack problem, it can be solved under dynamic programming. Traveling salesperson comes under dynamic programming, like that. So you have to remember the worst, best and average case time complexities of each application. Maximum divide and conquer strategy లో ఉన్న వాటికి ఎక్కువ టైం కాంప్లెక్స్ అడుగుతారు. సో డివైడ్ అండ్ కాంకర్ స్ట్రాటజీ యూస్ చేసి సాల్వ్ చేసే అప్లికేషన్స్ ఏమున్నాయో వాటికి మీరు టైం కాంప్లెక్సిటీస్ గుర్తుపెట్టుకోండి ఇన్ ఆల్ ద 3 కేసెస్, వర్స్ట్, బెస్ట్ అండ్ యావరేజ్ కేస్. ఓకే, సో ఇక్కడ ఇవన్నీ మనం డిస్కస్ చేసాము. సెలెక్షన్ సార్ట్, టైం కాంప్లెక్సిటీ ఎంత, ఇన్సర్షన్ సార్ట్, మెడ్ సార్ట్, క్విక్ సార్ట్, మ్యాట్రిక్స్ మల్టిప్లికేషన్. ఓకే, సో రిమెంబర్ దోస్ టైం కాంప్లెక్సిటీస్. So just for practice purpose, if the recurrence relation is 3 into t of n by 2 plus n square, what is going to be the time complexity? So here a equal to 3, b equal to 2 and c value is 2. So whether c less than log a base b or c equal to or c greater than అనేది దాన్ని బట్టి ఆ కండిషన్ బట్టి మనం టైం కాంప్లెక్సిటీ రాస్తాం. సో if it is 2 into t of n by 2 plus n log n, so what is going to be the time complexity? So next, this is about divide and conquer, and we have the next algorithm design technique is greedy method. So in greedy method, when we are going to apply this greedy method means, so when you are not in a situation to divide the problem into sub problems, and that means where you are not allowed to apply divide and conquer technique, then you will apply the greedy algorithm, greedy method. So here you are going to build up the solution step by step. So you are going to solve the problem for the given original problem in a step by step manner. So here whatever the problem you are going to solve, so you need to find the optimal solution for that given problem, for that complete problem. So at each step you are going to choose one of the inputs and you will check whether that input inclusion is going to give you the solution for the problem or not. So in general, for every problem you are going to have many feasible solutions, but among all the feasible solutions, which is the optimal solution you need to find. So by using greedy procedure, you are going to find that optimal solution. So optimal solution means whether it can be maximum or minimum depending on the problem. So మనకి some inputs ఇస్తారు, ఆ inputs లో ఒక్కొక్క input ని మనం select చేసుకొని whether that inclusion of that input is going to give you solution or not. If it is going to give you solution, you are going to add that input to the partial solution. If the inclusion of that input is not going to give you the optimal feasible solution, you are going to reject that input. Like that, you are going to include the input from the given list at each step and you are going to build up the solution for the problem. So among all the feasible solutions, which solution is the optimal solution based on the problem? For example, if you take knapsack problem, so you know what knapsack problem is. So you will be given a knapsack capacity and some objects will be given. For that objects, weight as well as profit will be given. So you need to find solution for that problem such that you should get the maximum profit. So in that case, optimal solution is nothing but the maximum value. But whereas if you take minimum spanning tree means a spanning tree whose cost is minimum. So in that case, what is the optimal solution means? The spanning tree whose cost is minimum. So the optimal solution is minimum value. So depending on the problem, It can be either maximum or minimum. The optimal solution you need to find for the given problem using greedy method. So you are not going to solve the problem at a time, but you can't divide that problem, but some inputs will be given, list of inputs will be given. You have to add each input at each step and you check whether that inclusion of that input will give you the output or not. So that is the greedy approach, where you can't apply the divide and conquer strategy. You are going to apply this greedy method. Okay. So this greedy method is more efficient than other techniques like divide and conquer. So in this we have different applications like minimum spanning tree, shortest path, fractional knapsack, job sequencing with deadlines, and like multiple storage on tapes, optimal storage on tapes. All these applications comes under the greedy method. So you know the knapsack problem. సో మనకి knapsack ప్రాబ్లం డిఫరెంట్ సొల్యూషన్స్ వస్తాయి. అందులో ఆప్టిమల్ సొల్యూషన్ అనేది మనం ఫైండ్ అవుట్ చేయాలి. మాక్సిమం ఆప్టిమల్ సొల్యూషన్ ఎప్పుడు వస్తుంది అంటే ఇఫ్ యూ ఫైండ్ ద ప్రాఫిట్ బై వెయిట్ రేషియో. సో యూ నీడ్ టు ఫైండ్ ఫర్ ద గివెన్ n objects, you need to find the profit by weight ratio, and you have to arrange that profit by weight ratio values in the descending order, and you select the object which has the maximum profit by weight ratio, and you have to put that object in the knapsack first. If you follow that order, you will get the maximum profit. Then that is going to be the optimal solution. So for example, here n equal to 5 objects has been given, and the knapsack capacity is 60, and its respective weights and as well as profit has been given. So among all this, you have to find the profit by weight ratio. So profit by weight ratio into profit first object ki 30 and its weight is 5. 30 divided by 5, 6. Next 40 by 10. Next 40 by 45 by 15. 77 by 22. 90 by 25. Like that you have to calculate profit by weight ratio. Once you calculate, so this is the profit by weight ratio values 6, 4, 3, 3.5 and 3.6. Among this, which has the maximum profit by weight, that you need to put first. So 6 is the maximum, and the next is 4, next 3.6, 3.5, now last 3. So follow the order, place the objects one by one until the knapsack has been filled. So if you follow that, then you are going to have the maximum profit. So here fractional knapsack means you will be able to put the part of the object also. సో ఒక ఆబ్జెక్ట్ కంప్లీట్ గా మనం పెట్టలేని కేసులో ఫ్రాక్షన్ ఆఫ్ ద ఆబ్జెక్ట్ ని కూడా మనం we can place it. So finally, which object you kept, that object profits will give you the total profit for that given problem. That is fractional knapsack. And job sequencing with deadlines application. So you will be given some jobs and you will be given some deadline time for each job. So here you will be, profit will also be given. Deadline time in the sense that is the maximum time or maximum waiting time for that particular job. So in order to solve this problem, so what is the maximum deadline among all jobs? Based on that many jobs you can include in the solution. So here the maximum deadline is 5, so you can include 5 jobs. So and depending on the time, so job 1 it can wait up to 5 minutes. If the unit of time is minutes anukunte, it can wait up to 5 minutes, whereas job 2 it can wait up to 3 minutes, job 3 3 minutes, job 4 2 minutes, like that. So a job takkuva waiting time untundo, and also if 2 jobs are such that among those 2 jobs which has the maximum profit, that job you have to include. So like that you have to include the jobs, and ఏ జాబ్స్ మనం తీసుకుంటే మనకి maximum profit వస్తుంది, that is the optimal solution for that given problem. So ఈ example లో మనకి you can include 5 jobs. So which job you can include first? So no job with wait time 1. So 2 waiting time to we have job 4 and job 6. So among job 4 and job 6, which has the maximum profit? Job 4. So we can include that like that. So job 4. Next job 4 తర్వాత మన job 6 కూడా waiting time 2 నే, but its profit is 100. సో దీనికన్నా ఇంకొక జాబ్ మనం ప్రాసెస్ చేస్తే మనకి ఎక్కువ ప్రాఫిట్ వస్తుందా అని చూసుకుంటే వస్తుంది. సో దట్ వీ కెన్ ఇంక్లూడ్ దట్ జాబ్ ఆల్సో లైక్ దట్. ఓకే, సో డిపెండింగ్ ఆన్ ద డెడ్ లైన్ టైమ్ and which job has the maximum profit, we are going to include that. And finally we will get the optimal solution for that. So we will have the 5 jobs in the optimal solution as the maximum deadline is 5. So in which order we are going to process that? So job sequencing with deadlines comes under the greedy method. Each time you are going to select a job and you are going to include that in the solution. Next, optimal storage and types. Optimal storage and types kuda it is going to, so we will be given some programs and we will be given, so its length, so which tape ante in the sense we have to go for sequential accessing. సో ఏ ఆర్డర్లో మనం వాటిని స్టోర్ చేసుకుంటే మనకి ఇట్ విల్ బి బెనిఫిషియల్ మినిమం టైంలో మనం రిట్రీవ్ చేసుకోవడానికి. సో ఆప్టిమల్ స్టోరేజ్ ఆన్ టేప్స్, ఇన్ విచ్ ఆర్డర్ వీ హ్యావ్ టు స్టోర్ దోస్ టేప్స్, దట్ మీన్స్ దోస్ ప్రోగ్రామ్స్ ఆన్ ద టేప్స్. సో ఇఫ్ యూ ఫాలో ద ఆర్డర్ 1 2 3, సో ఫస్ట్ ప్రోగ్రామ్ రీడ్ చేయడానికి ఇట్స్ లెంత్ ఈజ్ 8. So we have to wait for 8. Plus second program retrieve cheyadaniki again you have to start from starting of the tape, so 1 plus 2, so 8 plus 12. And third program ni retrieve chesukolante again we have to start from the starting of the tape, so 8 plus 12 plus 2. So overall if you store the programs in order 1 2 3, so time is 50. So you will take the average time 50 by 3. Next, if you follow the order 1 3 2, so its time is 40. And 2 1 3 54, 2 3 1. So different orderings మనం తీసుకొని ఏ ఆర్డరింగ్ లో మనం స్టోర్ చేసుకుంటే మనకి తక్కువ టైంలో మనం రిట్రీవ్ చేసుకోగలుగుతాం, ఓవరాల్ గా యావరేజ్ గా అనేది మనం ఫైండ్ అవుట్ చేస్తాం. సో అమాంగ్ ఆల్ దీస్ వాల్యూస్ 34 is the minimum value. So its average 34 by 3 is the time required to retrieve that program. So ఈ ఆర్డర్లో 3 1 2 ఆర్డర్లో మనం స్టోర్ చేసుకుంటే తక్కువ టైంలో మనం రిట్రీవ్ చేసుకోగలం కాబట్టి we will follow this order. So the optimal solution is 3 1 2. So these are the different solutions that comes under the greedy method. ఇంకోటి సింగిల్ సోర్స్ షార్టెస్ట్ పాత్ కూడా ఉంటుంది. if we represent a graph and each edge of the graph has been assigned some weight value, so we need to find the shortest path from single source. We will assume the starting vertex, or we will assume some vertex as the source and we will assume some vertex as the destination. So source nunchi destination ki what is the shortest path anedi we need to find. So source nunchi నెక్స్ట్ అడ్జసెంట్ వర్టెక్స్ ఏది మినిమమో దానికి వెళ్తాం. నెక్స్ట్ లెవెల్లో ఏ వర్టెక్స్ నుంచి నెక్స్ట్ లెవెల్ వర్టెక్స్ కి ఏది మినిమం డిస్టెన్స్ దానికి, అట్లా సోర్స్ నుంచి డెస్టినేషన్ కి ఏ వేలో వెళ్తే మనకి మినిమం కాస్ట్ తో మనం వెళ్తాం ఆర్ మినిమం డిస్టెన్స్ తో వెళ్తాం, ఆ పాత్ ని వీ హ్యావ్ టు ఫైండ్, దట్ ఈస్ సింగిల్ సోర్స్ షార్టెస్ట్ పాత్. దట్ ఆల్సో కమ్స్ అండర్ greedy method. At each step we are going to find what is the shortest nearest vertex to the source, and next what is the nearest vertex to that vertex. Like that we are going to find the nearest vertex at each level of that graph. So that is going to give you the shortest path from source to the destination. that application also comes under the greedy method, single source shortest path. And the next one is dynamic programming technique. Dynamic programming technique lo manaki algorithm ని మనకి డివైడ్ చేసుకుంటాము, బట్ హియర్ we are going to divide the subproblems where each subproblem is dependent on each other. Okay, divide and conquer లో అయితే subproblems అన్ని ఇండిపెండెంట్ గా మనం సాల్వ్ చేస్తాం, బట్ in dynamic programming we solve the given problem by breaking the problem into subproblems, but whereas each subproblem solution depends on the other subproblem. సో మనం అది ఆ subproblem యొక్క సొల్యూషన్ ఇంకొక subproblem యూస్ చేసుకుంటుంది కాబట్టి we are going to store the results of the subproblems in order to avoid recomputing the same problem again. We are going to store the results of the subproblems in dynamic programming. సో ఇక్కడ ఓవర్లాపింగ్ subproblems అండ్ ఆప్టిమల్ సబ్స్ట్రక్చర్ అనేది డైనమిక్ ప్రోగ్రామింగ్ లో అక్కర్ అవుతుంది. సబ్ ప్రాబ్లమ్స్ మధ్య ఓవర్లాపింగ్ అనేది ఉంటుంది. సబ్ ప్రాబ్లమ్స్ అగైన్ అక్కర్ అయినప్పుడు సేమ్ సబ్ ప్రాబ్లమ్ మళ్ళీ రీకంప్యూట్ చేయకుండా ద క్యాలిక్యులేషన్స్ విల్ బి స్టోర్డ్ ఇన్ ఎ టేబుల్. సో వీఆర్ గోయింగ్ టు యూజ్ దట్ వితౌట్ రీకంప్యూటింగ్ ఇట్ అగైన్. సో ఆప్టిమల్ సబ్స్ట్రక్చర్ అనేది మనం ఫాలో అవుతుంది. ఇక్కడ ప్రిన్సిపల్ ఆఫ్ ఆప్టిమాలిటీ అనేది డైనమిక్ ప్రోగ్రామింగ్ ఫాలో అవుతుంది ఇన్ ఆర్డర్ టు గెట్ ద ఆప్టిమల్ సొల్యూషన్. గ్రీడీ మెథడ్, it may or may not give you the optimal solution, but dynamic programming will compulsorily give you the optimal solution by following this principle of optimality. So that is the advantage of dynamic programming. Minimum spanning tree, I think it also comes under greedy method. So minimum spanning tree can be constructed using two algorithms, Prim's method and as well as Kruskal's method. So I think you know those methods. What is the minimum spanning tree means? What is the spanning tree first of all means? For the given graph which is having n vertices, you have to construct the tree. Tree in the sense it should be acyclic. So the tree should have n vertices and it should have n minus 1 edges. Then we call such tree as minimum spanning tree. Okay, so that can be called a spanning tree, and among all the spanning trees, which tree has the minimum cost, we call the tree as the minimum spanning tree. So for a particular graph we can have many number of spanning trees. So a spanning tree, it should be a tree and it is acyclic and it should have n vertices and n minus 1 edges. We call such tree as spanning tree. So by using Prim's and as well as Kruskal's, we can construct the minimum spanning tree. So what is the Kruskal's method means? We need to arrange the edges of the given graph according to the ascending order of their weights, and we have to take the first edge which has the minimum cost, and that will be the first edge that will be formed in the spanning tree. And next you have to take the next minimum weight edge, but while including that edge in the spanning tree, you should check that it should not form any cycle. If at all any edge inclusion is going to form a cycle in the spanning tree, you have to reject that edge. Like that, you have to include the edges in the spanning tree until the spanning tree contains n minus 1 edges. That is, up to that extent you have to add the edges. So this way of procedure of including or constructing the spanning tree is called Kruskal's method. And the other way, Prim's method లో ఏమంటే మనం ఇచ్చిన గ్రాఫ్ లో we will consider the starting ఏదైనా ఒక స్టార్టింగ్ వర్టెక్స్ తీసుకొని ఆ వర్టెక్స్ తో ఫామ్ అయిన ఎడ్జ్ లో which is the minimum that you will consider, and that is the first edge that will be formed in the minimum spanning tree. మీరు ఏ ఎడ్జ్ అయితే ఇంక్లూడ్ చేశారో ఆ ఎడ్జ్ లో పార్టిసిపేట్ చేసిన వర్టిసెస్ నుంచి ఏమైతే మళ్ళీ ఎడ్జెస్ ఫామ్ అయినాయో అమాంగ్ ఆల్ దోస్ విచ్ ఇస్ ద మినిమం దట్ యూ హ్యావ్ టు ఇంక్లూడ్. అండ్ ఇన్ ద రిజల్టెంట్ స్పానింగ్ ట్రీ లో ఏమైతే వర్టిసెస్ ఉన్నాయో వాట్ ఆర్ ద అడ్జసెంట్ వర్టిసెస్ టు దోస్ అండ్ విచ్ ఇస్ ద మినిమం దట్ యూ హ్యావ్ టు ఇంక్లూడ్. లైక్ దట్ యూ హ్యావ్ టు continue the process of constructing the minimum spanning tree by using Prim's method. Do you understood the difference between Kruskals and Prim's? And the time complexity is going to be order of E log E or N log N and అట్లైనా అనొచ్చు. E log E or N log N, where N is the number of edges in that given graph. And we have traveling salesman problem. Traveling salesman problem means we will be given a graph. So what is the shortest path from the starting vertex? Again, we have to go through all the vertices of that graph and we have to come back to the starting vertex. So అలా వెళ్ళడానికి మనకి ఏది షార్టెస్ట్ పాత్ అనేది కనుక్కోవడమే ట్రావెలింగ్ సేల్స్మెన్ ప్రాబ్లం. సో ఫార్ములా ఇస్ దేర్ ఫర్ దట్. ఫార్ములా యూజ్ చేయకపోయినా మనం డైరెక్ట్ గా గ్రాఫ్ ని చూసి కూడా చెప్పేయచ్చు వాట్ ఈస్ ద షార్టెస్ట్ కాస్ట్ టు గో ఫ్రమ్ స్టార్టింగ్ వర్టెక్స్ అండ్ అగైన్ going through all the vertices and coming back to the starting vertex. So its time complexity is order of n square into 2 power n. So remember the time complexities of each problem and divide. ఎలా ప్రాబ్లమ్ సాల్వ్ చేయాలనేది ఇది మన థియరిటికల్ ఎగ్జామ్ కాదు కాబట్టి there is no need to go for that. Directly by seeing by looking at the graph also, స్టార్టింగ్ వర్టెక్స్ నుంచి నెక్స్ట్ వర్టెక్స్ కి ఏది తక్కువ పడుతుంది దాని ద్వారా నెక్స్ట్ వర్టెక్స్ కి మనం ఏది రీచ్ అయితే వెళ్ళొచ్చు అనేది కూడా వీ కెన్ గో త్రూ దట్. నెక్స్ట్ ఆప్టిమల్ బైనరీ సెర్చ్ ట్రీ. సో ఫర్ ద గివెన్ నెంబర్ ఆఫ్ ఐడెంటిఫైర్స్ n value will be given. So for that given identifiers we have to construct the binary search tree. Among all the binary search trees, which tree has the minimum cost, we will call that binary search tree as the optimal binary search tree. And next we have graph lo manaki traversals, graph traversals వచ్చి depth first search and breadth first search. So what is depth first search means? So we have to start at the starting vertex and you have to go through among all its adjacent vertices. You have to go through one of its adjacent vertex and again for the vertex that has been included, again you have to go through one of its adjacent vertices. So vertically you are going to traverse the graph, so that is called depth first search. So backtracking will comes in this depth first search, where in some situations you will come to your node and there is no way to go or there is no way to traverse all the vertices, then you will come back and select some other adjacent vertex. So backtracking comes in the depth first search. Whereas in breadth first search, ఒక నోడ్ కి ఏదైతే అడ్జసెంట్ నోడ్స్ ఉన్నాయో వాటన్నిటిని విజిట్ అయిన తర్వాత నెక్స్ట్ లెవెల్ కి మనం వెళ్ళాలి. So the way of traversing. So for this graph, what is depth first search? So we'll go for A. A కి adjacent nodes BFS ఏంటి? A కి adjacent nodes ఉన్నవి BCD. So we have to visit all these BCD. Now for B, adjacent nodes is E and F. So next we will visit E and F. And for C, adjacent node is F, but it has been already visited, so we will not visit again. So A, B, C, D, E, F is the breadth first search. But coming to DFS, you will choose only one of its adjacent nodes. Anni choose save. So A ki BCD adjacent, but you will select only B. If you follow lexicographical order or alphabetical order, so for A you will select B, and for B adjacent node is E and F, but you will select only one of its adjacent E. Now at E there is no other adjacent, so what you have to do means you have to move back to its previous node, so that backtracking comes in DFS. So now for B, any other adjacent nodes which is not yet visited means we have to go to that. So for B, F is the adjacent and we have not yet visited, so we will go for F. And now for F, adjacent node is C, so we will go to C. And for C, there is no other adjacent node, so we will move back to from C to F. And again at F there is no other new adjacent node, we will move to B. And at B, is there any other adjacent node we have not yet visited? No. So again we will move back to A. And at A, any other adjacent node? Yes, there is. That is vertex D. So we will visit D. So this way of visiting the vertices in the given graph is called as depth first search. So the order of visiting DFS in this example is A, B, E, F, C, D. You understood the difference between BFS and DFS? Okay, graph ki BFS to DFS traversals reminder. You have to write. Understood all of you?
Yes, ma'am.
BFS, DFS. And again we have tree traversals. Tree traversals such as say in which order we are visiting the nodes of that particular tree. So we have three traversals: in order, pre-order and post-order. So first మనం left side తర్వాత root తర్వాత right ని root visit చేస్తే కనుక it is in order. First ని root తర్వాత left తర్వాత right visit చేస్తే it is pre-order. If we visit left and then right and then root, then we call it as post-order traversal. So these are the three ways in which we can visit. ఇక్కడ మనం ఒక different orders ఉంటాయి, but we have a principle that we have to visit the left subtree before right subtree. ఆ principle base చేసుకుంటే మాత్రం we will get these three tree traversals: in order, pre-order and post-order. So this is the, for example, ఈ example తీసుకుంటే what is the in order, what is the pre-order and what is the post-order. In order means first we have to move to left and then root and then right. So root నుంచి మనం స్టార్ట్ చేస్తాం. If we consider A is the root. దీనికి ప్రతి నోడ్ దగ్గర కూడా మీరు ఏ ఇన్ ఆర్డర్ అనుకోండి, లెఫ్ట్ రూట్ రైట్ అనే కన్వెన్షన్ ని ప్రతి నోడ్ దగ్గర మీరు అప్లై చేసుకోండి. లెఫ్ట్ ఉంటే మనం లెఫ్ట్ కి వెళ్ళాలి. ఏ కి లెఫ్ట్ ఉంది, ఎస్ వీ హ్యావ్ టు మూవ్ టు లెఫ్ట్. అండ్ అగైన్ at vertex B, follow the convention left root right. So is there left, you have to move to that left. So for B, left is there, so we will move to D. So at D, left root right. Left unte left ki ellali, but vertex D దగ్గర there is no left. So next what is there? Root. So we have to visit the root. So we are going to visit vertex D. So in order la first manam vertex D ni. Is there any right to this D? No. So we will move back to B. B దగ్గర left complete అయిపోయింది. Next we have to visit the road. So B ని visit చేస్తాం. So is there any right? Next E, right ఉంది కాబట్టి vertex E దగ్గరికి వస్తాం. Again at this vertex E, left root right. Left, no left, so root E. So E ని visit చేస్తాం. So like that you are going to at each node apply that convention in which order. In order means left root right, pre-order means root left right, post-order means left right root. So follow that convention. By following that you will get the traversal of that particular tree. So we have one more application, matrix and multiplication అనేది కూడా ఉంటుంది. ఏ ఆర్డర్ లో మనం టూ matrices ని మల్టిప్లై చేస్తే మనకి తక్కువ కంప్యూటేషన్స్ తో ఆ మ్యాట్రిక్స్ మల్టిప్లికేషన్ వస్తుంది అనేది ఆర్డర్ ని మనం ఫైండ్ అవుట్ చేయాలి. that is the application that comes under the dynamic programming, matrix chain multiplication. In which order we have to follow? We have to multiply those matrices. For example, ఇక్కడ 3 matrices ఇచ్చారనుకో, 4 matrices ఇచ్చారు ABCD. సో ఆ 4 matrices ని మనం మల్టిప్లై చేయడానికి ఫస్ట్ నేను ఏబిని మల్టిప్లై చేసి తర్వాత వచ్చిన రిజల్ట్ని సితో మల్టిప్లై చేసి తర్వాత వచ్చిన రిజల్ట్ని డితో చేయొచ్చు. ఆర్ అదర్వైజ్ I will multiply AB matrices and again I will multiply CD matrices and again the product of the resultant of those two matrices I can multiply, or I can follow some other order. I will follow first multiply B with C and then the resultant with D and then the resultant with A. So we are going to have different orders of multiplying those matrices. So in which order we have to compute such that we will multiply all those matrices with less number of computations. Order ni find out చేయడమే matrix chain multiplication. సో అలా కంప్యూట్ చేయడానికి ఇన్ జనరల్ మనకి ఇక్కడ మ్యాట్రిక్స్ ఆర్డర్ ఇస్తారు కదా, సైజ్ ఆఫ్ ద మ్యాట్రిక్స్. సో డిపెండింగ్ ఆన్ దట్, ఫర్ ఎగ్జాంపుల్ ఏ మ్యాట్రిక్స్ వచ్చి 10x30 అనుకోండి, బి వచ్చేసి 30x5 అండ్ సి వచ్చేసి 5x60 అనుకుంటే కనుక, ఇన్ ఆర్డర్ టు కంప్యూట్ ఫస్ట్ ఏబిని మల్టిప్లై చేయడానికి ఏబి మ్యాట్రిక్స్ యొక్క ఆర్డర్ ఎంత 10x30 30x5. సో మీరు 10 into 30 into 5 కంప్యూటేషన్స్ కావాలి. నెక్స్ట్ ఆ వచ్చిన రిజల్టెంట్ ని సి తో మల్టిప్లై చేయాలంటే మీకు సి మ్యాట్రిక్స్ రిజల్టెంట్ మ్యాట్రిక్స్ ఏబిని మల్టిప్లై చేస్తే రిజల్టెంట్ మ్యాట్రిక్స్ ఏమొస్తుంది, 10x30 30x5 అంటే 10x5 వస్తుంది. సో again C matrix is 5x60. So to compute that 10x5x60, 10 into 5 into 60. So summation of these two will going to give you 4500 operations. అంటే 4500 computations మీరు చేయాలి టోటల్ ఏబిని మల్టిప్లై చేసి వచ్చిన రిజల్టెంట్ మ్యాట్రిక్స్ ని సి తో మల్టిప్లై చేయాలండి. బట్ వెరాజ్ ఇన్ కేస్ ఆఫ్ ఫస్ట్ బీసీని మల్టిప్లై చేసి తర్వాత నేను ఏ తో మల్టిప్లై చేస్తే ఇన్ దట్ కేస్ యు ఆర్ గోయింగ్ టు హ్యావ్ దీస్ నెంబర్ ఆఫ్ కంప్యూటేషన్స్, 27,000 కంప్యూటేషన్స్. సో ఈ రెండిట్లో మనకి ఏది తక్కువ టైం తీసుకుంటుంది అంటే 4500 ఈజ్ లెస్ నెంబర్ ఆఫ్ కంప్యూటేషన్స్. సో నేను ఆ 3 మ్యాట్రిసెస్ ని మల్టిప్లై చేసేటప్పుడు ఫస్ట్ నేను ఏబిని మల్టిప్లై చేసి తర్వాత సితో చేస్తే ఐఎమ్ గోయింగ్ టు కంప్యూట్ ద మల్టిప్లికేషన్ ఆఫ్ దీస్ 3 మ్యాట్రిసెస్ విత్ లెస్ నెంబర్ ఆఫ్ కంప్యూటేషన్స్. సో దానికి టైం కాంప్లెక్సిటీ వచ్చేసి ఆర్డర్ ఆఫ్ n క్యూబ్. సో ఏ ఆర్డర్ లో మనం మల్టిప్లై చేస్తే మనకి తక్కువ కంప్యూటేషన్స్ తో మ్యాట్రిక్స్ మల్టిప్లికేషన్ జరుగుతుంది, ఆ ఆర్డర్ ని మనం కనుక్కోవాలి. సో మీకు మల్టిప్లికేషన్ ఒక సైజ్ ఇస్తారు, మ్యాట్రిక్స్ సైజ్ ఇస్తారు, ఆ ఆర్డర్ ని కనుక్కోమని చెప్తారు. ఆప్షన్స్ లో డిఫరెంట్ ఆర్డరింగ్స్ ఇస్తాయి. ఏ ఆర్డర్ లో మీరు మల్టిప్లై చేస్తే మీకు తక్కువ కంప్యూటేషన్స్ తో క్యాలిక్యులేట్ చేస్తారో మీరు ఫైండ్ అవుట్ చేయాలి. దట్ ఈస్ మ్యాట్రిక్స్ చైన్ మల్టిప్లికేషన్. 0 or 1 knapsack ప్రాబ్లం అంటే డైనమిక్ ప్రోగ్రామింగ్ లో మీకు greedy method లో you have the possibility of putting the fraction of the object, but whereas in case of 0 or 1 knapsack you will be able to put that object either completely or not. So 0 కానీ 1 కానీ ఉంటుంది. xi వాల్యూ అనేది xi is nothing but the fraction or part of the object you are putting. ఆ xi వాల్యూ అనేది 0 కానీ 1 కానీ ఉంటుంది 0 or 1 knapsack problem. If you are not able to put that object completely means you will not put it. So that is 0 or 1 knapsack problem. 0 or 1 knapsack problem ni solve cheyadaniki manam dynamic programming lo we will follow sets use chestamu and we will follow some dominance rule and as well as మెర్జింగ్ అండ్ పర్జింగ్ రూల్ అనేది ఒకటి ఉంటుంది. సో సమ్ కండిషన్ విల్ బి దేర్ డిపెండింగ్ ఆన్ దట్. యాక్చువల్గా ఇదంతా మనం థియరిటికల్ గా రాయడానికి, బట్ మీకు ప్రాబ్లం యొక్క సొల్యూషన్ డైరెక్ట్ గా మీరు ప్రాబ్లమ్ ని చూడంగానే చెప్పచ్చు. ఏ ఆబ్జెక్ట్స్ ప్లేస్ చేస్తే మనకి ఏ ఆబ్జెక్ట్స్ మనం కంప్లీట్ గా పెట్టగలం, కంప్లీట్ గా పెట్టలేమో మనకి తెలుస్తుంది. డిపెండింగ్ ఆన్ దట్ ప్రాబ్లమ్ వాట్ ఈస్ ఆప్టిమల్ సొల్యూషన్ యూ కెన్ డైరెక్ట్లీ రైట్ ఇట్. అండ్ ఫర్ దిస్ టైమ్ కాంప్లెక్సిటీ is order of n into w, where n is the number of objects and w is the weight of the that means capacity of the knapsack, and its space complexity is order of m into n, order of mn అనుకోండి. m is the capacity of the knapsack. Traveling salesman already we have discussed. And in backtracking method lo backtracking we can able to move. Backtracking method we are going to take the input one by one and we will check whether the inclusion of that input మనం సొల్యూషన్ ఇస్తుందా లేదా అనేది మనకి ఒకవేళ పాసిబిలిటీ మనం వెళ్ళే పాత్ లో సొల్యూషన్ రాదు అని మనకు తెలిసినప్పుడు వీ కెన్ మూవ్ బ్యాక్ అండ్ వీ విల్ గో ఫర్ అదర్ alternate path that is possible in backtracking method. So backtracking applications వచ్చి Queen's problem, and we have sum of subsets problem, and we have what is the other graph coloring problem, and we have Hamiltonian path. All this comes under backtracking. So graph coloring means you have to color the graph such that no two adjacent vertices have the same color. So what is the chromatic number of the given graph, you will be asked. So you have to color the vertices of the graph such that no two adjacent vertices have the same color. You can color the graph properly with maximum colors, but you have to color with minimum colors. So that is the chromatic number, not the maximum number of colors. And next, the time complexity for that graph coloring problem is order of n into m power n. And next we have Hamiltonian graph. Hamiltonian graph means you have to cover the vertices of the graph by visiting each vertex only once. So ఆ path ఉంటే గనుక Hamiltonian path starting vertex నుంచి you have to again come back to the starting vertex by going through all the vertices of the graph only once. If such path is there in that graph, we will call such graph as Hamiltonian graph, and this can be comes under backtracking method, Hamiltonian path. And Queen's problem అంటే మనకి ఎన్ని ఎన్ని సొల్యూషన్స్ ఉంటాయి అనేది అడుగుతారు, లేదా స్టేట్ స్పేస్ ట్రీ మీద అడగచ్చు. So these are the theoretical concepts that comes in the again what is NP problem, what is polynomial time, అంటే ఏ ప్రాబ్లమ్ ని మనం polynomial time లో సాల్వ్ చేయగలుగుతామో that called as polynomial time problem, that is P. And if we can't, we will call it as a non polynomial NP problem. సో ఇంకా వీటి మీద బిట్స్ ఏం కవర్ అవుతాయి, కవర్ చేయొచ్చు మనం అనేది నేను బిట్స్ మీకు నెక్స్ట్ 3 క్లాసెస్ లో ఓన్లీ బిట్స్ మీద చెప్తాను, ఇంకా థియరిటికల్ కాన్సెప్ట్స్ ఏమి చెప్పను. I will cover what type of bits that will come for the GATE exam. Bits and its solutions I will cover. Do you understood these concepts?
Yes, ma'am.
Okay then. So in the next classes